Okay, today we're going to talk about converting exponential functions to logarithms. So the inverse of y equals a to the x is equal to log y log base a x. So I'm just going to rewrite this on the top because this is really, really important. If I've got um, uh, y equals a to the power of x, that's the same thing. This is exponential form. Okay. This is the same thing as writing log base a x equals y. So why on earth would we want to write this like this if we're solving for the exponent x? If we're solving for x, we want it to be in this form. We can't solve for x in the exponent like this without doing a graph on the calculator or something else. So, um, so today we're just going to be practicing converting it from exponential form to log form and vice versa. Okay, so um, so let's start off this way. So if I've got a to the power of x equals c, that's just how it's written down here, right? So these things have special names. So where's my red pen? Disappeared. Okay, so this right here is called the exponent. You already knew that. This here is called the base. Okay, and this thing right here is called the argument. Okay, so we're going to be using this vocabulary to, if I talk about the exponent, the base, or the argument, I want you to have an idea of what it is I'm talking about. So if I want to write this in logarithmic form, I'm going to write this as log. My base is 2, so I'm going to put the 2 here in a subscript. And then I need to write the argument next, which is 8. And the exponent goes over here. Now let's just say I didn't know that it was 3. I would think to myself, 2 to what power gives me 8? And we know that 2 cubed gives me 8. So my exponent, so this is now the exponent. This is my base. And this is the argument. Okay, so there's new vocabulary here, and there's new things that we're trying to switch things around, and so this is all about the practice. So same thing here for here. To convert this to logarithm form, I'm going to write log base a c equals b. Okay. And here I'm going to, now we're going to write it in exponential form. So my base here is the 5. My power is the 2. The exponent is 2. And my argument is 25. Okay. So, on my other answer key, I color-coded. I want to use the same color coding. So my base, I'm going to color code in blue. My argument, I'm going to color code in yellow. And my exponent, I'm going to color code in pink. So In a little bit, I'll be just showing my answer key when it's time for you to check to make sure that your work is correct. But we're going to do the first um, few problems together. Okay. So I have my base, which is a, the exponent, which is 2, equals the argument. If I convert it to logarithm form, I've got my base, which is the subscript here, I have the argument, and I have the exponent written by itself over here. We're doing this in order, we convert it from this to this in order to solve for the exponent. So, you might want to hit pause. The log represents the inverse function of the exponent. The functions can be used to solve for x when it's the exponent. Okay? Alright, so let's do some problems. Okay. 3 to what power gives me x? So we have 3 to what power gives me 3. So, what did we just do? My base is 2. My base here is 3. My exponent is this thing over here. So, I'm going to put an x there. And my argument is 3. So 3 to what power gives me 3? We know that x equals 1. 4 to the power of x gives me 4. Well, you know x has to be 1. 5 to the power of x gives me 5. We know x has to be 1. I hope you guys are seeing the pattern. A to the power of x is going to give me a, x equals 1. So what is this telling us? That the exponent is 1. The exponent is 1 when the base and the argument are the same. Base is 2, argument is 2. Base is 5, argument is 5. So you want to copy this down. The exponent is 1 when the base and the argument are the same. Okay? So 11 and 11, we know that x is 1. 5 and p, we know that p is going to have to be 5. Q and 3, we know that q is going to have to be 3. Okay. Let's do number 4 together here. Now, let's write this in exponential form. 6 to the power of x is equal to the argument of 1. 7 to the power of x is equal to the argument of 1. 8 to the power of x is equal to the argument of 1. So, what power do I have to have in order to get 1? X is going to have to be 0. Anything to the 0 power is 1. So x is going to be 0 for all of these here. Okay, so when the argument is 1, then the exponent has to be 0. So when the argument is 1, the exponent has to be 0. Okay, you want to hit pause and copy that down. And I wrote this over here. You may want to hit pause and write this down onto your paper as well. I think this is super, super important. As I said before, for the rest of this handout, I'm going to be highlighting the base blue, I'm going to be highlighting the exponent pink, and I'm going to be highlighting the argument yellow. Okay. Okay. how can you write 1 in logarithmic form? Okay. So what we've just learned is that if the base and the argument are the same, then the value is going to be, the exponent will be 1. This is the exponent, right? Different bases can be used to represent the equivalent values in different ways. So these are the main things. So so whenever I have any, it doesn't matter what base it is. If this is 1, we know a to the power of 0 is going to give me 1. So if this is 1 here, we know the exponent has to be 0. If the argument is 1, the exponent has to be 0. And if the base and the argument are the same, then we know that this has to be 1, because the base a to the power of 1 is going to give me a. Okay, these are things that we're going to be using repeatedly, and you'll be able to use the calculator to verify that this is true. Okay, so explain why the a cannot be equal to 0 or a negative value. So we mentioned this kind of in class the other day, and I just want to make sure you have this in your notes. So 0 can be the power. 0 to any power is always 0. If a is negative, then when the exponent is even, the argument's going to be positive. When the exponent is odd, the argument is going to be negative. Okay. All right. So we're going to practice using this relationship, converting to exponential form. So here I've got 7 to the power of 2 equals x. So x is going to have to be 49, because 7 squared is 49. Okay. Here, let me do these with you. Okay. I'm going to rewrite this as 25 to the power of 1/2. Okay. And so my base, here's my exponent, and here's my argument. And using this relationship, I'm going to rewrite this in logarithmic form. I'm going to write this as log base 25 x equals 1/2. Okay. It didn't say solve, it just said write it. Oh, well, we guess we could solve. We know that the square root of 25 is equal to 5, right? So I guess we could solve this. We could write this as log base 25 with the argument of 5 is equal to 1/2. Now, on my calculator, I can't do base 25. So all of these need to be done by hand when the base is not 10 or when the base is not e. Because we can do log base 10 using this button, and we can use log base e using this button. But right now, we're just dealing with different kinds of bases here. Okay. What is the value of this? So if I write this in exponential form, it'll help me think of this. I'm going to just say this is equal to x. That might help me get started. So I'm going to write this in exponential form. My base is 2, the exponent is x, and my argument is 32. So I think of 2 to what power is going to give me 32. And I already know that it's going to be 5. But let's just pretend I didn't know it was 5. We could check it with a calculator. 2 to the power of 5 is 32. So x has to be 30. X has to be 5. Okay. Let's do a few more together. And then I want you to try these on your own and just use my answer key to check your answers. Okay. Write these in exponential form. P to the power of r is equal to q. 3 to the power of r is equal to 5. Here, if there's nothing there, it's going to be base 10. 10 to the power of x equals 11. Let's write this one here in log form. Log base r t is equal to s. Okay, here are my answers. Check your work. Okay. Hit pause. Okay. Now I want you to hit pause and try to do these on your own. Okay. Are you ready for your answers? I hope you hit pause. Try doing them on your own. Okay. Here are the answers. Made sense? Okay. Here are these guys. Now notice these ones here with the fraction. Those are probably trickier, right? If we write this in exponential form, 25 to the power of x gives me 5. So we know 25 is 5 squared. So square root of 25 is going to give me 1 power of 1/2. The exponent's going to have to be 1/2. But let's just say I didn't know that it was square root. Let's say, because we know 25 is 5 squared, right? And if I have this to the power of x equals 5, when I have a power to a power, like here, this means I multiply, I have 2x. So I have 2x equals 1, but I'm going to have x as 1/2. Okay, G is a little tricky. Let's talk about this one. Let me do this with you guys. Okay, so if I've got 1 over 27, let's think of this as log base 3, 27 to the power of -1. To take this fraction and move it into the numerator, I can put it to the power of -1. And then I can also think of this as log base 3. 27 is 3 cubed, right? So 3 cubed to the power of -1. This is log base 3, 3 to the power of -3. Okay, so I'm just going to make this equal to x, right? So I have 3, my base is 3, right? 3, my exponent is going to be x. So we have 3, oh, I can't see what I'm doing, can you? 3 to the power of x is equal to my argument. My argument is this. Okay, so after switching it to this form, it should be clear that x has to be equal to -3. If that didn't make sense, hit pause, rewind a little bit, see if you can make sense of it. Is that the end of this handout? I guess so.